In this video, we will discuss about the confidence interval of variance. Variance we denote by sigma square and standard deviation is just sigma. So we want to find, based on the sample variance and sample standard deviation, we want to find the estimates for the population variance and population standard deviation. So the population variance and population standard deviation are very important in statistics. For example, when products that fit together, such as pipes, are manufactured, it is important to keep the variations of the diameter of the products as small as possible, because even all the pipes are made from the same machines. All the pipes may not be exactly the same, 100% same, okay? So they may be very little different, but the two pipes or nuts and bolts, they fit each other if the variation is very small. But if the variation is bigger than certain number, then they do not fit together, okay? So also in the manufacture of the medicine, the variance and the standard deviation of the medication in the pills play an important role in making sure that the patient receive the proper doses. So these things are important, okay? To calculate this confidence interval for variance and standard deviation, a new statistical distribution is needed. We don't use normal distribution, or we don't use G distribution or T distribution there. Okay, we don't do inverse G, inverse T, or normal CDF and TCDF. We don't do that way, okay? So we use a different distribution. It is called chi-square distribution. The notation is that, okay, chi-square distribution. The chi-square variable is similar to the T variable in that its distribution is family of curves based on the number of degrees of freedom. For chi-square distribution, we also need the degrees of freedom. So degrees of freedom is given by sample size -1, okay? The symbol for the chi-squared is that it is like x square, but it is not exactly x. It is like this, and then this is square. We call chi-square, okay? For the confidence interval of variance and standard deviation, we need to use chi-square table. Okay, most of the calculators, they do not have chi-square values or inverse chi-square in your calculator, so we need to use table. So table is given here later. So unlike G and T distribution, the chi-square distribution is more skewed to the right. It is not normal distribution. It is skewed to the right, or right tail distribution, positively skewed distribution, and all chi-square values are greater than zeros. Like normal distribution has 0 in the middle, right? Normal distribution has 0 in the middle. So G distribution has 0 in the middle, and it has some negative values on the left and then positive values on the right? But the chi-square values has all positive values. But the area under the chi-square curve is 1. This is what the chi-square distribution look like. Okay, so the area under the whole chi-square curve is 1. Okay, as the chi-square distribution is not symmetric, to find out the confidence interval, you need to find out both chi-square left and chi-square right values. The bound for the right is the chi-square right. The bound for the left is the chi-square left. Okay, so how do we find out chi-square left and chi-square right values? So the idea is this. So we have find the chi-square values, means chi-square left and chi-square right values for 95% confidence interval when n is 25. So the sample size is 25 and the confidence interval is 95%. So 0.95 is in the middle. This white region is the 95% or 0.95. So since the total area is 100%, so the outside area, that is these two shaded region, should be 5%, right? Because the total is 100%, the middle is 95%, so it is 5%. So but we need to divide that 5% into this half and the other half, right? So 5% divided by 2 will be 0.05 divided by 2, that is 0.025. So this area is 0.025 and this area is 0.025. Now, one of the difference between the other distribution and this chi-square distribution is, on the chi-square table, the right area is needed. Okay, so we use the right area to find out the chi-square right value. So for example, to find out the chi-square right, what is the area right of this number? Is 0.025. So what we will do, and the n is 25. N is 25. So what is the degrees of freedom? Degrees of freedom is n minus 1. That is 24. So how do we look at the table is, let us see the table here. So what was the right area in our case? 0.025, right? To find out this number, we need the area right of that is 0.025. For chi-square left, the right area is 0.95 plus 0.025 will be 0.975. The right area will be 0.975 for this. For this value, the right area is 0.025. Let's look at the column of 0.025 in the table. 0.025. What is the degrees of freedom? 24, right? Because n is 25. So the degrees of freedom is 24. So 24 degrees of freedom. Okay. And the column of 0.025. So 39.364. We will get that 39.364. So the chi-square right value will be 39.364. Now, to find out the chi-square left, the total area right of chi-square left, this number, total area right of this number, because chi-square table needs right area. To find out the chi-square values, we need the area right of that. So 0.95 plus 0.025 will be 0.975. So the right area will be 0.975 and 24 degrees of freedom. Okay, 0.975 and 24 degrees of freedom. See, this is 0.975 and this is 24 degrees of freedom is 12.401. So this value will be 12.401. Okay, so this is 12.401. That's what you get. See, I'm doing exactly the same thing. N is 25, degrees of freedom is 24. So 1 minus alpha is, that value is 0.95. So implies alpha half is 0.025 because this 1 minus alpha, the middle value is 95. So outside value, this shaded value will be 5%. Since this 2 is 5%, so 1 is 2.5%. So 0.025, 0.025. And again, to find out the chi-square right and chi-square left, we need the area right of that value. Okay. All right. Let us do, this note says that we need right area right of the value. Also, we can be used to find out chi-square value is the given left area. So there may be some table that may give you that way. Okay. All right. Number 2, find the chi-square values. You need to find the chi-square right and chi-square left. Okay. Let us draw the chi-square distribution. It is longer tail on the right. For 98% confidence, 0.98 is in the middle. So what is outside this middle region is 2%. 2% is 0.02. So divide by 2 will be 0.01. This is 0.01. This is also 0.01. 0.01. This is called chi-square right because it is on the right end. This is called chi-square left. It is on the left end. To find out the chi-square right, we need the area right of that 0.01. So on the table, go to the column of 0.01. 0.01. What was the sample size here? Sample size was 12. So the degrees of freedom is 11, right? N minus 1. So go to the 11th row and then 0.01 column. 0.01 and 11th row. See, 11th row and 0.01. So it is 0.01 right here. 11th row and 0.01. So 24.725. This value will be 24.725. 24.725. Now I want to find out the chi-square left. What is the area right of chi-square left? 98 and then 1% is 99, right? So we need to look at the column of 0.99 because the area right of this number is 98% and 1% is 0.99. Let's go there. So 0.99 and 11th degrees of freedom. So 0.99 and 11 degrees of freedom is that value. So one value is that, the other value 3.053. Right? 3.053. So 3.053. So for every problem, if you want to find the confidence interval for variance sigma square or standard deviation sigma, we will need chi-square left and chi-square right. Now what is the formula to find out the confidence interval? The formula is n minus 1 times s square over chi-square right. That is the first bound, and the second limit or the left bound, and the right bound will be n minus 1 s square. The numerator is same, only the denominator is, for the first one you go that value in the denominator, second one that value in the denominator, okay. And this is for sigma square, for the variance, n minus 1 s square over chi square right is less than sigma square is less than n minus 1 s square over chi square left. You can write this way too, okay. This is for variance. So after you find the answer, if you want to find the standard deviation, you need to take the square root for all of these, okay. Let us do example. Example number 3. A study of generation related carbon monoxide deaths showed that a random sample of 6, that means n equals to 6, has standard deviation is 4.1. So S equals to 4.1. For the sample, standard deviation is denoted by S. For population, standard deviation is denoted by sigma, okay. Find the 99%. So confidence interval is 99. That is 0.99. So we need to find out chi-square left and chi-square right, right? 0.99 is in the middle, okay. So 1% is 0.01 is outside. The shaded region is 1%. So because there are two shaded regions, divided by 2, 0.005. 0.005. This is chi-square right. This point is chi-square right. This point is chi-square left. What is the right area? For this, chi-square left is 99 and 0.05. So 99.5, 0.995 is for chi-square left. And what is the degrees of freedom? It's 6 minus 1, that is 5. So to find out the chi-square right, you use the area right of chi-square right, that is 0.005. Look at the table. 0.005 and degrees of freedom is 5 because the n was 6, right? So degrees of freedom is 5. So this is what? You will see 16.750. So you will get this value is 16.750. To find out this value, what is the right area is 0.99 plus 0.005 is 0.995, and degrees of freedom is again 5. So we need to look at 0.995, 0.995, and the degrees of freedom is 5, 0.412. That's what you get, okay. So let us do that. This is 0.412. Now we want to find out the confidence interval for variance and standard deviation. For variance, the confidence interval is n minus 1 s square over chi square right, comma n minus 1 s square over chi square left. If you do that, what is n? 6 minus 1 s square is 4.1 square over 16.750 and comma 6 minus 1 times 4.1 square over 0.412. That is the confidence interval. So let us use calculator for these, okay. If you use calculator, what do you get is, there is no direct way to do the confidence interval for variance. You will have to do by hand, okay. So this is 5. 6 minus 1 is 5 times 4.1 square, right? 5 times 4.1 square divide by that's divide by 16.756. So 16.756. If you do that, you will get 5.02. So 5.02 is the left bound, and for the right bound, you can copy the same thing, second, and then that. Only the denominator thing is changed, right? So 0.412. So this is 0.412. And then the other one is delayed. So 0.412. The numerator is same. So 204.0. So 204.0. This is for sigma square. For sigma square. But to find out the value for sigma, you need to take the square root of this and that. Okay. For sigma, you need to take the square root of the variance. So what is the square root of 5.02 is 2.24. Similarly, square root of 204.00 is 14.28. So for it is 2.24, 14.28. So 2.24 and 14.28 for the population standard deviation. This is for variance and this is for standard deviation. That's how we find out. Okay. So what are the things we need? Is we need S square, we need N, and we need chi-square left and right to find out that. Chi-square left and right are found by using the table, and the right area degrees of freedom. Okay. Let us do this problem. Okay. Let me see if there is anything on the next page. No. So let us do this problem. On this problem though, the data is given to you. You need to find out the sample size and you need to find out N and S. You need to find out N and then S. Okay, we need to use calculator to do that. Let us enter these values in your calculator. How do I enter the value in your calculator? Is go to the stat and then edit and enter the value. I want to enter the value in L3 because they are already saved, so I don't want to delete them. Okay, so what are the data? Let us enter the data. 17, enter 42, enter 20, enter. I think I missed 41 there. Okay, so let me enter that 41 at the end. Okay, since I missed 41 on the third, I missed this data. When I enter, I miss that data, so I can enter at the end. There is no problem because order does not matter here. So what I want to do is I want to enter 41. So 41 there. Okay, hit enter. So there are total 17 items, 17 data points. So you need to do stat and then calc and then one variable status, and we are entering these values in L3. So I pick L3 there, and then frequency list, there is no frequency, and then calculate. What you get is N equals to 17. So N equals to 17. And what is S? Basically your S value is 10.163, right? So I want to do 10.163. These are the S. So what will be the degrees of freedom? Degrees of freedom is 17 minus 1, that is 16 degrees of freedom. So we need degrees of freedom to find out chi-square left and chi-square right, because your formula is N minus 1 S square over chi-square right, comma N minus 1 S square over chi-square left. Okay, this is the formula for the confidence interval. So what is the confidence level is 95%. So 95%. So let us make the graph. It is right tail, right? 0.95 is in the middle. So you need to divide that remaining 5%, 0.05 into 2 ends, that is 0.025. 0.025, this is chi-square right, that's the notation. This notation is chi-square left. Okay, we need the right area right of that to find out this value. So what is chi-square right? Right area is 0.025, degrees of freedom is 16. So 16 degrees of freedom with right area 0.025. 0.025 is here, 16 degrees of freedom is here. That is the value. Similarly, so this is let me write down that value first. So 28.845. Okay, 0.025, 16 degrees of freedom, 28.845. that is for chi-square right value. And for chi-square left value, to find out this value, the right area is 95%, right? Right area is 95%, and this is 2.5%. So 97.5%, that is 0.975. 0.975. Where is 0.975 is here, and 16 degrees of freedom is here. 6.908. What do you get? 6.908. 6.908. That's what you get. Now plug in these values in your formula. So N is 17 minus 1 is 16 times S square is 10.163 square over. You don't have to square. The notation is chi-square, so you don't square it. Okay, you just write that value. The notation itself is chi-square. You are not squaring anything. It is just a notation. Is 28.845. That is the left value. For the right value, 16 times. For the right bound, 16 times 10.163 square over. What is the chi-square left? Chi-square left is 6.908. 6.908. Now you use calculator for this. What do you get? If you use calculator, let me use that. Clear what I have. So 16 times 10.163 square divide by 28.845 to 8.845. That's what you get. So 57.29. So it will be 57.29. That's what you get for the first number. For the second number on the confidence interval, you copy that and then change the denominator only, because the numerator is same, 6.908. So what you do is 6.908. Okay, and then remove the extra thing. If you do that, you will get 239.22. So 239.22. This is for variance, for sigma square. But what is for sigma? Find the 95% confidence interval for variance and standard deviation, I think, right? Yeah, for both variance and standard deviation. So you need to find out the confidence interval for both. So for standard deviation, you need to take the square root of that. So second and then square will give you square root 57.29. 57.29 give you 7.57. So 7.57, that is the lower bound, and the upper bound will be the square root of 239.22. 239.22. That's what you do. You don't need the parenthesis there because we did not start with the parenthesis. So let me delete that parenthesis. Hit enter. You get 15.47. So you get 15.47. That's what you get. This is for sigma. Okay. This is how we find out chi-square left, chi-square right, and then the confidence interval for population variance and population standard deviation. Okay, guys. Thank you.